everything for us. But in the y equals, if you plug in y equals 2x plus 4, that goes into y1. There we go. And then the second one is going to go into y2. So 2x plus 4 in y1, negative 3x plus 44 in y2. And then hit graph. Why do we only see one line? Gavin? Awesome. So the second line started at 44, which is way up on the y-axis. That's why we only see one line. But that's okay, because I want us to look at the table. So in your calculator, there is a table of values that lists all of the values on your lines, x, y, depending on how many lines we have, y1, y2, y3, y4. And that table is right above the graph. Once you graph an equation, there are a table of values that represent that equation. And if you hit the second graph, it pulls up your table. So now in this table, I have the x, because x is going to be the same. But we have two different y values because they're two different lines with different heights of the line. And you can see, like when x is 0, the y-intercept of the first line was 4, the y-intercept of the second line was 44. See if you can scroll down in that table and decide when they would meet. What would the solution be? You go to second y equals, you have to turn your stop clocks off. So you got it. Anybody else? Anybody else not graph? So in the table, when are they the same? Maggie? Yeah. So if you scroll down in your table, at the x value of 8, they have the same y value. So that means that's the point where they're crossing. That's the solution. When x is 8, y is 20, they're meeting at that point. So without even kind of seeing both graphs, we can use the table to help us get an idea as to where they're intersecting. And that would be you doing no algebra, just using your calculator to kind of help you through the problem. And it's definitely there so that you can check your work. But this is one way that you can kind of look to see what's going on with the lines, check out the table, and we'll be using that various times. Depending on what we're doing, we'll refer to this table of values. Questions? So in your packet, if you'll open it up to the first page, there's a couple of vocab terms. And then we are going to look at graphing today. So today we're focusing on solving equations by graphing. Tomorrow we'll look at solving equations using substitution and elimination. There are 3 ways to solve a system of equations: graphically, substitution, elimination. So between the 2 days, we're going to talk about all 3 of those methods. And just to give a little review of some vocab terms. First term we have here is a system of 2 linear equations. So Julian, what makes it a system of 2 linear equations? What does that mean? What do we just do in the calculator? Say it again? They equal each other. So a system of 2 equations is just literally like graphing 2 lines on the same grid. It seems. So we can say to find when they intersect, to find when they equal each other, to find when they meet, any of those words. So then a solution is the point where they meet, where they cross, where they intersect. Whatever word you want to use there. So intersect, cross, meet. But it is a point. So it's not just an x value, it's an x and a y. And that's what you could kind of see in the table. So you'll have an x value and a y value. Both of those go together. So it's not just x, but we need both, the ordered pair. Because if two lines are being graphed and they cross on a graph, they're meeting at the x and y value. So there are two other terms that might not be as familiar with you, and that's called consistent versus inconsistent. And this refers to systems. So systems are one or the other. And a system is graphing two lines. So now we're graphing two lines, not just one. A consistent system has a solution. Or it could have many solutions. We'll look at cases where it has one, where it has many. So essentially, a consistent system has an answer. It has a place where they're meeting. So consistent means there is an answer that we can find for that system, for the pair of lines. Therefore, inconsistent would be, what do you think inconsistent is? Julian?
The lines never intersect.
Yeah, the lines never intersect. There is no solution. So consistent means they have to meet somewhere because there's an answer to the problem. Inconsistent means there's never a solution. That would be the answer, just no solution because they're not intersecting. Julian, what kind of lines would intersect? Parallel lines, yes. So we'll look at parallel lines. Parallel lines are those two lines that run next to each other, the same slope, same steepness, never intersect. That is considered an inconsistent solution or system because it does not have a solution that satisfies both x and y values. So if you look at the first graph, we're going to do it by hand. We're going to check our work using the graphing calculator. It wants us to graph the system and estimate the solution, and then it says check algebraically. We'll also check with the calculator, so multiple ways to kind of check your work here. So essentially, you should not be wrong because there's a way for you to check easily just by using the calculator. So everybody should always be correct with these problems if you take the time to check your work. So the first equation, 4x plus 2y equals 4. How do we graph that system? How do we graph the line? Emma, what would you have to do to graph 4x plus 2y equals 4? So one thing we could do is find both the intercepts. Awesome for thinking that. So we could get the x and the y intercept and plot the 2 points on the x and the y axis. That would be one option. What's the other option that we could do? Connor?
Put it in a line.
Place it into y equals 4. Both of them work. It depends what you want to do. So you either find the x and the y intercepts by plugging a 0 in for x or y, or you get it in y equals 4, whichever you're more comfortable with. I'm guessing 95% of you probably will get y by itself. So we would subtract the 4x. Make sure you place that x in front if you're getting it in y equals form, mx plus b. Divide by 2. And we end up with negative 2x plus 2. So that's line 1. We have 2 lines, so we'll have to do that a second time. Just be careful when you're dividing by negative 3. So if we're dividing this by negative 3, we have positive 2/3 and then minus 10/3. Careful with the negative sign. So the first one is going to be a little easier to graph than the second. So graphing it like we did last chapter, if you're using slope-intercept, we start with the y-intercept, move with your slope. Make sure you make a couple of points because our goal is to figure out where these lines cross. So we need a couple of points on the graph so that we can see if they're intersecting at those points. Negative 10/3 is equal to what? Where would we graph negative 10/3? How far down the y-axis, Julia?
You go down 3 and another 3.
Yeah, 3 and then a third after that. So it makes it a little harder because we're graphing a fraction. And then you're moving up 2 over 3. It's a lot easier when you have a point that's plotted right on another point because it definitely says, hey, this is an exact answer. But, Julia, where does it look like these lines are crossing? 2, negative 2. Yeah, looks like they're crossing at 2, negative 2, right here. That's where it appears for those to be crossing. Again, if I don't have a point graphed on top of another point, it's a little hard to tell. So it says to check your solution algebraically. So to check it algebraically, if you have a solution, you can plug it in for x and y and make sure that it holds true. So I'm going to do that just to show you how it works algebraically, then we'll use the calculator as well. So here's my check. So we have 2 and negative 2. So 4 times 2 plus 2 times negative 2, that's supposed to equal 4. So I'm checking it into the first equation. And here we have 8 minus 4, which 8 minus 4 does equal 4. So check it in the first one, we're good to go so far. So you're taking the solution that you get, you're plugging it into the first equation, making sure that it works. The second equation said 2 times x, so x was 2, minus 3 times y. That's supposed to be equal to 10. 2 times 2 is 4, negative 3 and negative 2 make 6, and 4 plus 6 does equal 10. So that means we found the correct solution. If it works in both of them, then it is a solution. So underneath, we graph both equations. The solution appears to intersect at 2, 2. And of course, underneath there, I could have shown the check stuff as well. The last thing I think it says is to check with your calculator. So I'd like you to plug the equations into the calculator. You already have them in y equals form. So go back to y equals, plug those two equations in, clear out what you have. So 2x plus 2 is a negative 2x. Negative 2x. And then we had 2/3. I'm going to put mine in parentheses, that fraction. And then minus 10/3. All right, so now you know one way that you can check this by looking at the table of values. That's one option. However, if it doesn't meet at an exact area, the table of values will not help. If it crosses at a decimal, your table of values only give whole values for x. So if it crossed at 3.5, looking at the table of values will not be helpful. But just looking, kind of showing you, here's the x value of 2, y is the same at negative 2. Another way to check to see where they intersect is actually using an intersection function of the calculator. So if you hit the second trace, underneath or above that it says calculate. So we're going to go to second trace. We will be using all of these functions 1 through 5 pretty regularly, but there's an option to find out where lines intersect. This is beneficial when the line intersects at like 3.75 and 1.25, not at exact locations of whole number values. You just need to hit enter. So it's going to say first curve. That just means it needs to be on the first line. Second curve, it hopped to the second line. You never do anything for guess. That's just the calculator kind of trapping our number in. And then you hit enter. And it shows you that intersection of 2, -2. Questions? So please, when you're doing your homework tonight, check your work in the calculator. You have to do it by hand. Show me the work to get it in y= form. But please take the 30 seconds to check to make sure it's correct, especially on your test or quiz. So if you'll flip it, if you need to write those directions down to remind yourself what you did, please make sure you do that. So we went to second trace in the calculator and we hit number 5, intersection. So second trace and then we did number 5 where they intersect. So at the top of the next page, I believe there is another example. Graph the linear system, estimate the solution, use the calculator just to check to make sure. So get these in y= form, or find the x and y intercepts. Either is an option. But you must have algebraic work to support your answer that you're finding in the calculator. It's fine, use the calculator to check your work, but you've got to have algebraic work to support your solution. Matt, what 2 equations did you get?
Y = -4 x minus 2.
Okay,
Y = -2 x minus 4.
thanks. So line 1. And line 2. My lines are sloppy. Matt, where'd you get them to intersect at?
1 - 6.
Nice job. 1 - 6. So check them with the calculator, plug them both in, make sure they hold true. Just do a quick little check to confirm that yes, they are correct. So y = 4, show me a little bit of work getting them into y = 4, those 2 equations that you're using. Are there questions? So underneath there are 3 different graphs with 3 options that we could have for systems. So when we graph a system, we can have 3 different types of solutions, and apparently I didn't erase this page. So the first option is when they intersect at one location. And when graphs intersect at one location or one point, we say that they are consistent. We also say that they are independent. So not only are they consistent, which means they have an answer, but because they're intersecting at one point, they're independent. So you can have a consistent system that is independent, one line intersecting with another. The middle option is still a consistent system, but we say it has infinitely many solutions. Because every point on the first line overlaps with every point on the second line. And they end up being the same exact line once you get them in y=4. So you're graphing one line, you're graphing the other one right on top. So infinitely many solutions, you can write that as IMS if you'd like, instead of writing out infinitely many solutions. But that means every single point on the first line connects with every single point in the second. So any x and y value that we pick would be a solution, infinitely many solutions. That is also consistent, but it's dependent. Because one line depends on the other crossing it at every single point for a solution to exist. And then the last option we talked about on the front page is when we have parallel lines and there are no solutions. So consistent means there's an answer. If it's independent, we have one answer. If it's dependent, we have multiple answers. So I believe there are two other graphs on the top of the next page. And then I think we have a word problem, maybe? Yeah. Always have to throw a word problem in. Make sure we do some applications. And I'm going to clear my note. So see if you can solve yours. Don't look at mine. So graph both of those, and then we'll fill in the blanks below. So for the first equation, you should have had y=2x plus 4. The second one is also y=2x plus 4. Bless you. Bless you. And instead of rising 2 and moving right 1, we can also fall 2 and move backwards 1. You still get the same line, you're just kind of looking at a different portion of the line. So underneath, there are two little fill in the blanks. It says the graphs of the equations are overlapping. You could say the same. But the first graph of line 1 overlaps or is the same as the second graph of line 2. So each point on the line is a solution and the system has infinitely many solutions. I'll just put IMS there instead of writing it all out. Therefore, we say the system is consistent. And I'm also going to put dependent on there. I'm pretty sure that might be part of one of your homework questions or sections. So that one's dependent because the only way for there to be an answer or multiple answers is for that one line to overlap with the other. So one line depends on the other for all the answers to exist. So any point on that line is a solution, as long as it's on that line. The second one, does anybody have these solved in y equals form? Odette, what do you have?
And the first one is y equals 1/2 x plus 2.
And then the second one?
Y equals 1/2 x minus 1.
Nice. So if you look at the slopes, if the slopes are the same, the lines are parallel when the y-intercepts are different. So same slopes mean parallel lines, but the y-intercept's different. That makes them then not the same line. So the first one starts up at 2. The second one starts down at -1. So the graphs of these equations are parallel. So same slope, different y-intercepts means we have parallel lines. The lines do not intersect, the system has no solution, therefore it is inconsistent. So consistent has one answer or many answers. Inconsistent means parallel lines do not intersect, there's not a solution. Any questions? Okay, so there is a word problem on the next page. So an ice cream shop, one customer pays $9 for 2 sundaes and 2 milkshakes. A second customer pays $13 for 2 sundaes and 4 milkshakes. How much do each sundae and milkshake cost? I think ice cream is my favorite dessert. I love ice cream. Great snack to have. Ice cream and pizza. I could live off that every single day. I might be fat by the end of my lifespan though if I had ice cream and pizza every single day. Does anybody else love ice cream? Only a couple of you? Milkshakes, ice cream? Favorite ice cream at Brewster's, Graham Central Station. Does anybody know what I'm talking about? Graham Central Station? It's a really good choice. There's like graham cracker crumb in it and chocolate. The ice cream is like a creamy flavor. It's not just your typical vanilla. I think it might be a graham flavor ice cream. Go try it at Brewster's. Or I think Candace has it too. Not Dairy Queen though. They don't have that kind there. Now we can go for ice cream after school today. Sounds like a good idea to me. I don't think it's open right now, otherwise we could all go right now. That might be frowned upon, but Alright, so looking at the equation, we have a verbal model here. The verbal model is a way for us to kind of think about how to set up the equation for the information we're given. So our total cost would be equal to the number of sundaes times the cost of a sundae, plus, because we also have a milkshake, so the number of milkshakes times the cost of a milkshake. So if we want to come up with an equation, we have to take the number of what we're purchasing times the amount that they cost. So Will, can you give me an equation for customer number 1? So how much did customer number 1 pay for his? $9. And how many sundaes did he buy? 2. We don't know how much they cost, so we're just going to say that one's X. How many shakes did he buy, Will? And again, we don't know how much that costs, so we'll just say Y. So if you don't know the cost, you get 2 different variables because we're talking about 2 different types of desserts here, a sundae versus a milkshake. Gabby, how about the second equation for customer number 2?
13 and 2x plus 4.
Nice. So take the information you have, create 2 equations. Now we're going to try and graph it. There's a little nice graph underneath, only the positive values because you can't find negative milkshakes. You can't find negative sundaes. And if you like having your y on the left side, you can flip that. So I have 2y is equal to negative 2x plus 9. And when we divide by 2, we end up with negative x plus 9/2 or 4.5. The second one, 4y, and then dividing this by 4 gives us negative 1/2 x plus 13/4, which is a little more than 3.25. So this one's a little harder to graph because we are dealing with decimals, fractional values. So this is when the calculator might be beneficial to help us see where they connect with each other. So the first one, 9/2, is 4.5. Fourths is 12 over 4, which is 3, and then an extra fourth, so 3 1/4. And I will check your calculator because mine doesn't look like a very nice graph. Hopefully yours crosses at a nicer location than mine does, because you can't really purchase half of a sundae. I guess you could have a cost of $2.50 though. So then look in your calculator. And find the intersection point. This is talking about money, talking about the cost. Try to get mine to be close. So a good example as to when you would want to use the calculator to help you find the intersection point. And then use the intersection function of the calculator. Instead of guesstimating and saying, oh, it looks like it could be about $2.50. So Julian, what did your calculator tell you about the intersection point?
It's 2.52.
Which mine looks pretty close to that. So intersecting right here at this location, looks like the x is about 2.5 and the y is 2 from my graph. We can verify that algebraically, you can verify it using your calculator, but please make sure that you answer the question. So the question says, how much do each sundae and milkshake cost? So we have this ordered pair of 2.52, but what does it really mean? Did anybody not get that in the calculator? I'm sure your calculator's there. Anyone need help with the calculator? Please ask. Brock, do you know what that 2.52 really means?
The cost of a sundae every the cost of a milkshake.
Yeah, so the cost of the sundae, $2.50, pretty cheap sundae. And the cost of a milkshake is $2. Any questions? So make sure with the word problem, there are 2 of them that you have, those last pair of problems. Make sure you're answering the final question. How much do they cost in this case? So your homework is in your book, pages 156 and 157. There are 12 graphs that you'll be doing, so you have 12 graphs that I passed out to you at the beginning of class. Please make sure that you have worked with your equations, either on a separate piece of paper or in the margin above, below those graphs. Julia,
Have the goods come yet?
I will have to look. I will let you know tomorrow. I can see if I can get some information about that. I'll have to ask. Anybody interested in presenting 21 or 35 tomorrow? Julia, you'll do 21. Holly, you want to try 35? And Julia, I will see about getting information for the books.